Alright, so today we're going to go over when it is proper to replace an LED driver versus when you should troubleshoot other things in the circuit. So right now we have an old piece of crap, an A1278, and on this machine you get no backlight, but you do get a chime. So the first thing that you want to look for before doing any troubleshooting in a backlight circuit is, does it turn on and chime? Now, for some reason, this decided to not turn on and chime because I hit the record button on the camera, which is very, very typical. So what I do is I look at the machine and I like to see, am I getting a picture? The first thing above all else that I'm interested in is, do I get a picture on the screen? So here, if I put this up to the lighting, you'll see that I have a picture. Actually, you can't see I have a picture because this user is really, really disgusting and nasty and has a screen that's so fucking dirty that you can't see that there's anything showing up on it. So you're just going to have to trust me when I say that there is indeed something there. I can see through the dirt. Sadly, my camera cannot. So the first thing you need is a picture on the screen. No picture on the screen, no troubleshooting backlight. Now we're going to go check out the board a little bit. So let's just switch over to the screen capture over here and find the board view in the schematic. So this is an 820-3115. Okay, we switch over. Ah, that made me deaf. Fucking software. All right, so let's check out the backlight area. All right, so there are a few basic things I want to check. The first thing I want to see is there power on backlight enable over here? So this needs to get 3 volts or 2.7 volts at BKL_EN. If I don't have power there, then this is not gonna do it. First thing we do is check out the BKL_EN area. So let's go over to that. Whoa, the schematic that I have open just changed. I don't remember doing that. That's scary. Okay, so here we go. So BKLEN. Now this is going to tell me a few things over here. If BKLEN is 3 volts, the first thing that I know is that the computer detects a screen because these signals over here would not allow the backlight power to flow through to that part of the circuit because backlight enable voltage comes from this PP bus SW LCD backlight per. Over here you see PP bus SW LCD backlight per. And that would not show up if this was an opening. This is not going to open unless these two open and allow this voltage divider to allow this transistor to open. And this is not going to come through if the computer is not turning on and also seeing a screen. If this fuse is blown, that's also not going to work. So what I do is, if I see 3 volts there, I can rule out the fact that this entire circuit could be part of the problem. So let's see what I get. So at backlight enable, when I choose voltage on the multimeter, I get 2.7 volts. So it is being told to turn on. Okay, what's up next? What's up next is BKL_PWM. Now, this is going to be what sets the brightness. It's going to be a little pulse that sets brightness, best measured with an oscilloscope, but you can totally get by measuring this with a multimeter. There's no reason to buy an oscilloscope to measure this. I get 3.095 volts, which is high enough to set brightness. That is doing its job. Now, I can't really check if 5 volts is going to this chip because I can't shove this thing underneath the underneath the chip and touch the ball. That's not possible. So at this point, the chip is being told to turn on. I can check at the capacitor. I can check at this capacitor that's on the rail over here to see if there's 5 volts at least being sent to it, and I have that. So all of that is good. At this point, I have every reason to believe the LED driver is bad. Let's just go over this again. So A, it sees a screen. B, the chip is being told to turn on. There's power going through the circuit, and there's no reason for this to not be turning on. I can now logically conclude that it's time to replace the chip. But you can't replace that LED driver chip just because you have no backlight. There are so many reasons that you could have no backlight that have absolutely nothing to do with the chip being bad. But under these circumstances, once you've gone through this initial assessment and you get those measurements, now you can at the very least say, maybe I have a problem with my LED driver. So with that being said, I'm going to grab myself another LED driver and we'll get started. Okay, over here we can see the LED driver chip. It looks like it's pretty in focus. So we're going to turn the air filter on and get started. Now it's freezing in here, So it may take longer to remove components than it takes when it's not freezing in the office. Now I'm going to remove the micro soldering pencil to put on the proper iron for this. So it's going to beep. That's what Hacko stuff does. It beeps really annoyingly for no reason. I think that's their way of telling you should buy a more expensive station. Sometimes I wonder if Hacko owns JBC and Pace and some of these other companies, or if they're a subsidiary of them and they purposely make their gear do annoying things just to add value to other products. Because as I said in the video with the JBC versus the Hacko, yeah, the hot air station, it has some benefits, but the actual soldering tools, specifically just the hand soldering or doing, these irons, I could not notice a difference at all. It seemed the same to me. The only difference is that the JBC one doesn't bitch at you every time you turn it on and off and switch. Not that that's worth an extra $1,000 or so for the gear, but don't get me wrong, it's tempting at times. Trust me, it's quite tempting at times. Okay, so at this point we find the new LED driver. Now the reason I'm doing this is I don't want the flux to just be on the board. I want it to get on the every single solder ball as well. Because the solder balls are what actually need the flux on them. So now I take this. The most important thing, as always, is that the chip is sitting flat on the board and that it's a nice solid physical connection before we even get the soldered connection. Okay, it just dropped. Now we move the hot air back and forth so that the chip kind of dances a little. That's how I know that all the balls have melted. I move it away. I can be confident that it was soldered properly. Now I get to see if this thing actually works. So, is that the proper diagnosis of the problem, or have I just been talking out of my ass for 10 minutes? Let's see. Oh, cool. I have not been talking out of my ass for 10 minutes. See? Light. So it was the chip. And that's how you can tell if it's the chip versus something else. And those are the test points that you should probe and check voltage on before you decide to replace a chip that may actually work. And that's that for today.